Hello and welcome to Cracking the Cryptic. And bonus content continues, but I'm not really sure what's going on with this puzzle. Simon has asked me to do it just as it's presented, and I don't know what he means by that. We shall see, maybe. Well, I probably won't find out during this video, but I'll probably find out later. And you may know why already. I don't know. So, this is by ProwlingTiger. And the rules are that in the cages, the sums are the sums of the numbers, but all nines in the puzzle count as 0 for those sums. Normal Killer Sudoku rules apply, so cages have to be filled with different digits, and normal Sudoku rules apply. So that's the rules, and I shall give it a go in a moment. Firstly, just to remind you or let you know that on Patreon we have Neil Talbot's solve of a listener numerical puzzle, which is quite entertaining. I think particularly mathematicians, but also logicians generally, will enjoy that. Very much worth a look. And now I'm going to have a go at this. You can try it on the link under the video, although I don't know, if Simon's shown you the puzzle already today, you may not need that, but we are going to have a go now. Let's get cracking. So I've seen this 9 cage. That is less than 10 and it's 4 cells, so that has got to have a 0 in it. I mean, obviously the 0, basically I'm going to treat this as a 0 that gets written as a 9. But every time I see a 9, I'm going to have to add 0. That's how I'm treating this puzzle. I hope that's not violating what he wants. So the 10 here could be 1, 2, 3, 4, or it could have a 0 in. It's tricky if you can't find cells which have definite zeros. That 3 is either 2, 1 or 3, 0. 18... I suppose the big numbers are a bit different, aren't they? 24. So the most this can be is 8 plus 7. No, that's still 8 plus 7 plus 6 is 21. No, that's not big enough. But 15 must be 8 and 7. Because 9 is 0. So does that mean I know what 14 is? 6 plus 5 is 11. No, definitely not. 8 plus 7, is that very helpful? Doesn't feel it. But 29 here. 45 minus 9, so 36. 36 is the sum of each row, column, and box. So this 3 cells is worth 7, and normally I'd just write in 1, 2, 4, but here there's 4 possibilities. Could be 0, 1, 6, 0, 2, 5, 0, 3, 4, or 1, 2, 4. Crikey, it's kind of a bit backwards, isn't it, in that respect, this puzzle? How am I going to find how to do any significant things in it? It's tricky, isn't it? So the 9 has a 0. Is that... could still be 2, 3, 4. The 10 and the 9, though, together. Maybe even with the 12. No, the 10 and the 9 together, that's 19. So even if you had 2 9s, i.e. zeros, the other 4 digits would have to add up to 19, but they don't all have to be. That one and that one could be the same as those two. 3, 6, 9, 10, 13, not very helpful. 13, I suppose that has to be 8, 5 or 7, 6 in this puzzle. So it uses either the 8 or the 7. This 16 must use the other of the 8 or the 7, given that they're both ruled out of these 3 cells. But we're still left with the problem that this 7 quite likely has a 0 in it. This is tricky. This is tricky to even kind of understand how to find the sums with zeros in. So that 19, 8 plus 7 plus 6, it's 21. Yeah, that could even have a 0 in it. I suppose maybe we could look at the full totals down here. So 36 times 2 is 72. These cages occupy 15 of the 18 cells. They add up to 22, 40, 49. That leaves 23 of the 72? Is that even possible? We can't use a 9, but we don't have to, because that could be the same as that. I think they both have to be 8s, and I think that is the break-in, effectively. So they, I think, are both 8s, and this is a 7, and those 3 digits make 23, 41, 50, 60, 72. Yes, that must be right. Okay, so this 18, is that now 6543? Yes, it is. So here we have the 1, 2 and 9 in this row. Ooh, 18 there. I just wish this was more help. Surely the 7 can't be in the 10 cage? Oh, it can. It could be 7120. Frustration. It would be nice to have a ruling on that. So there's got to be an 8 in this 18 cage. And I was about to say, so clearly there can't be a 9, but I'm forgetting the value of the 9. One of these has a 7 in, either the 12 cage or the 10 cage. Which one? I do not know. 29 in those 2 cages, those 3 cells add up to 7 as well. But again, these add up to 7 and those add up to 7. So, oh no, they could both have a 0 in. I was just thinking the way they pointed at each other was useful, but I don't think it is. Right, this 3, this is 1, 2 or 0 here. That has to be a 3. Yes, in that cell. This therefore is a 9, i.e. 0. Now, so we've got 3 of the 36 there. Another 1 there is 6. Oh no, maybe the way to look at it is 18 plus 3 is 21. The other 3 cells have to make 15. Ooh, even if that was the maximum 3. Yes, this can't be 8 and 7. That's right, this is 7 and 6. 1 and 2 are outside the 13 cage, the 18 cage. I think that's right. That makes this a 9. If that's right, this has to be 8, 5, 4. I think this is right, although the numbers are so strange here. I think that 6, 7 is the maximum I could do there. And I needed all of that to be different from 18 plus 3 is 21. If this was smaller, yeah, that would have to be bigger. That's not possible. That is right. Okay. So the 7 in column 2, I don't think it can be in the 9 cage, because that would have to have 0, 1 and 2. So it's there. And it shares that cage with 0, 1 and 2. 4, 5, 8, 7. Well, this now is 9, 1, 2, 6. Ooh. No. That's not working. Something's gone wrong. What has gone wrong there? This 9 cage can't have 7 in it. No, it can't. It would need a repeat. The 10 cage must be 7, 1, 2, 9. But where's 3 going? if 6 is in this cage, which it must be, and 3 must be, I've definitely done something wrong. Let's undo. I mean, I think I was good up to the 18 cage, but then something in column 7 did seem like it might be a bit wrong. Let's try again with that 6, 7. Now, 3, 4, 5, 6, I'm right about that. That's the maximum it can be, and that's 18. I'm assuming these are right. 20, so these have to be 1, 2, and 0. Now, the most this can be is 13. 31, 34. Ah, I've misadded it up, haven't I? 18, 21, 7 and 6 would be 34. This would be 2 and 0 to make 36. Right, I got my addition wrong. So this is either 7 and 6 or 7 and 5, because there's 1 degree of freedom. There's definitely a 7 in it. Now the same logic about the 7 applies. Where can it be in column 2? It's got to be here. So that's right. So these are 2, 1 and 0, which I write as a 9. That one is not a 9 because there's a 9 in this box. This, what have I deduced? It either can't be a 0 or it can't be a 2. Right, if this is 7 and 6, 13, 16, 34, that would be 2 and 9, that would be a 1. Why would I choose that? 7 and 5, 12, 30, 33, that would be 2 and 1, and that would be a 9. So this can't be a 2. There's definitely a 2 in one of those. 4 and 8 must be in this one. Now, does the same apply? Yes, 3 and 1 of these, 6 or 5 are in this, and we established a moment ago it can't be 3 and 6, because then you'd need another 0. So it's 3, 5 and 1 in this. Yeah, that is 9, 3, 5 and 1. So that's a 2. This is 4, 8 and 6. So 6 is not in here. Let's take the 7 out of the corner. 8, 10, 18. This is the 0, which is what I said before, and it fell apart. But I think that's because of what I was doing wrong in box 6. So let's take the 9 out of there. Right, now those are not 2. In fact, we know which way round the 1 and 9 are because of the 9 in row 3. 6, 4 and 2 here, 2 there, 6, 4 there. Does that tell us about this? No, could be 5, 1 or 0, 6. Stupid logic with zeros, it's so tricky. Now, that 9 is well positioned for this 19 cage. It sees every cell in it. Oh, well, there's a 9 there, so obviously they do. But 8, 7, that could be 8. Then this could be as much as 7, 6, 5. Oh, that would be 26. I thought it felt like 19 was a big number for a 4 cage, but it's not in this form of Sudoku. Got that wrong. Wow, where do I go now? Okay, these aren't 9 and 1, so I can narrow down the pairs. I don't think it's going to help me with the rest of the grid. They're not 3 and 5. They're not 4 and 6. Okay. Ah, that 7 is looking straight at that. Bit of ordinary Sudoku. Not that I think it's going to help me much. Ah, 7 is looking at that. I've got to look at these 7s looking across at things. So 5 and 8 are there. So this involves a 7 and some numbers adding up to 9. Still, I don't know if there's a 0 in this column. 24 has been appealing for some time. 7, 9, 8, 5. So the most we could have here is 9. 6 and 3. And that would leave 15 here. Oh, maybe... No. Well, we pulled this trick with those 3 cells here. Now I'm tempted to look at these boxes which must add up to 36 times 3 is 108. But they don't include these 3 cells. So, what do we add up to? 24, 40, 53, 62, 80. Then there's also 987, that's 24. That's 104, 106, 107. Oh, brilliant. These 3 have to add up to 1. Is that right? That can't be right. I must have done the maths wrong because it doesn't work. Oh, because that's a 0. Oh. So they have to add up to 10, which is not... Or is it not a helpful number? No, it's not really. These 2 could be anything. And I don't trust my maths anyway. Right, the most these 3 could be 18, not very helpful. If that was 5 and 1, would that help? All those digits see everything in this. Could be 0 and 6, then that would be a 4. Doesn't look that helpful. Oh, this is a frustrating puzzle, but I expect that that's the point. That can't be an 8 at least. There must be a 7 along there somewhere. 17 there. 24, 33. 9, 7, 5, 8. I'm just still wondering if the maximum there is going to be part of this sum, but there's no reason why it has to be. 8 there. Doesn't really get me anywhere. This 16, no. I mean, it's all dependent on what this 7 sum is in those 3. Where is 9 in this column? Can that be a 9? Easily. These 2 add up to 29. Oh, hang on. No, 29. Yeah, that still leaves these to add up to 7. They can't have a 0 and a 1 in, though, because of that cell. But still, 1, 2, 4 is possible. Or 0, 1, 6, 0, no, not 0, 1, 6, 0, 2, 5, or 0, 3, 4. I mean, they all feel possible. Can it have a 2 in here? Yeah, 6, 4, 2, 0, easily. 5, 8, 9, 7. What questions should I be asking here? I don't know, and this is proving very tricky indeed to me. And there's a 9, i.e. 0, somewhere along here. Ah, yes, right, that's 6. That's been staring at me for ages and me thinking it could be 9 and 6. Well, there's a 9 there. The problem was I was thinking it could be 0 and 6, and then I don't notice that's ruled out because that's not a physical 0. So that's 1 and 5. That one is a 7, and that's 5. You just have to look at things differently in this puzzle. So this could be 2, 3, and 6. It can't be 2, 4, and 5 because of the 5's there. It can't have a 1 in it because of the 1's there. So it can be 2, 3, 6, or it could have a 0 there. But then this couldn't be 6, 5, or 8, 7, or 8, 3, or 7, 4. Brilliant. So this has to be 2, 3, 6. Yeah, it's the only thing possible in this cell. In this box. Cage, that's what it is. Right, so can take 0, i.e. 9 as a possibility out there. That fixes this pair. 4 and 6. This is now an 8, 9 pair, in fact, i.e. 8 and 0. Now, can that be 8? Yes. Oh, I don't like this puzzle much. 9, 3, 1, 8, 2. Now, they're not 5. In fact, this is either 4 or 6. This one, slightly more freedom. 9, 3, 8, 1, 2, 5. 4, 6, or 7. This, 2, 5, 9, 6, 1 ruled out, but still 3, 4, 7, 8. I think that's just too much freedom around this 19 sum. Two. It could theoretically be a 2. What would that be? 17 for the rest? Yeah, 4, 6, 7. Easy enough. Ah, but this 2 is not part of this 7 sum, so it must have a 9 in it, i.e. 0, because it can't be 1, 2, 4. It's also not 0, 2, 5, so it's either 0, 1, 6 or 0, 3, 4. Which forms a quintuple with those, i.e. 5 in the column has to be there. That sorts out 3 and 5. Right, that must help with this. So these make 29, so these make 7, so that must be 5, 2 and 0. 1 and 9 there. It's 1, 2, 9. So this is 1, 4, 3, 6. And I know nothing about their disposition within the box. Now, this is either... This has to involve the 1 now, doesn't it? So it's 9, 1, 6. That one's not the 9. So this is 3 and 4. Excellent. That is helpful. That's a 6. This is not 3 or 4. That is not 3 or 4. Surely my possibilities are now narrow. 8, 7, 4. That would be too much because that would need a 9. 8, 6, 4 would need a 1. So that, ooh, please make this work. 7, 13, 17, yes, needs a 2. Okay. 5 and 7 here, and that's already 12 of the 17 sums. So the 0 goes in there. These add up to 5, which are 1 and 4. We get a 3 here, 8 here. That sorts out the 5, 8 cage. 5, 2, 9, 3, 1, 6. Ah, God, it's not giving up here, is it? So, 8, 5, 9, 7. These are from 4, 6, 8, 7. Because that's all that's left in the row. That one's the only uncertain one. That's a pair. No, those can't be 6. Don't know. Oh, 5 and 1 are sorted out. So those can't be 1. 2 and 9 have been resolved. Should just try doing some regular Sudoku, shouldn't I? So 7 is not here. Well, 7's in one of those. Let's take it out of the corner. 2's in one of those, and the others are 3 and 4. Now, we've got 2 in there and 2 in there. So 2 over here must be in one of those two. Doesn't look that helpful. 8, 5, 9, 7. 3, actually, that's a 2, 3 pair, weirdly. Because 2 and 3 are looking down there, and we still need 2 and 3 in the row. So this one is 1 or 4, because there's a 6 up there. This is not 6. Now, I was wondering about these two. I suppose, ooh, they have to involve the 4, because otherwise, oh no, not quite. They could be 6, 7 and a 1, but that can't be 0 because of that. So it could be 6, 7, 1. It can't be 4, 6. That would go with a 4. Could be 4, 7, 3. Oh, curses. Or 4, 8, 2. So I can't take any one of those digits out. Irritating. Now here, just feels like there's too much freedom to narrow it down from those. This 9 cage with 2, 3 already gone in the box. So 0, 1, 7 is possible. And otherwise, 4, 5, 0. Yeah, those are the only two possibilities. So 0's in the cage and it has to be there because of that 9 up there. So this is either... No, hang on. 0, 1, 7 does not add up to 9. 0, 1, 8 adds up to 9. 027. No, can't be. 036, no. 045. And you can't use two numbers above 3 and 1 below unless it's 450. Yeah, that. There has to be a 0. This is either 45 or 18. And I can take the 8-1 possibility out one way around because of this 8. Now that 9, yes, that's putting a 9 there. Have I got any triples or quadruples along the bottom? No, I haven't. So 2, 3, 9, 1, 4, 5, 8. We've got to get 6 in the box. That's got to go there. Now, at some point, I worked out what these had to add up to, didn't I? I made it 10. I'm gonna trust my maths and go with a 3 there and a 1 there. No, let's use the 6 instead. That's the simpler way. 1 there, 4 there. Oh, I do want to trust my maths now. Oh no, maybe I can just use this 24 gauge. 10, 19. We need another 5. Oh, we can't use a 9. Oh, hang on. Something's gone. Please don't say something's gone wrong now. 10, 19. Only 5 more. How am I going to do that without using a 0? Ah. Oh, I can't bear the thought that something's gone wrong now. Well, let's keep trying on the other bits. That's got to be 9. I can't see how this is going to repair itself though. Oh, that's 0. It's not 9. Phew. Okay, 10 used in the box. Okay, well, let's just keep going elsewhere. Okay, at least I'm not knocked out as I thought I was. It's so hard to keep remembering that 9 represents 0 when it so often represents 9. 8, 6, 9, 8 and 6. 6, 3, 2, 9, 4. 1 and 8. One of these is a 5. I'm going to have to do the maths on this box now and get it right. Right, that's 10 so far. We've got to have a 7 in, haven't we? Because there's no other place for a 7 in this box. And actually, forget the maths for a second, that fixes this as an 8. 1 above it, that's not a 1. This is now not an 8. So 7 has to be in there with either 6, which would need a 1 there, so that's not possible. So 7 and 4 in that too. 11, that's a 3. That's 4. That's 6, yeah. This is 3 and 1. Even just regular eliminations feel odder in this context. 5 and 6 there. Yes, yes, yes. 5 and 7. Yes, 4 and 7. Yes, 1 and 4. I'm finally finishing this head-wrecking puzzle. That's 1 and 8. Nearly got that wrong on its own. 3 there, 2 there. Let's sort out the rest of this. 1, 2, see what we get left with. So 2, 3, 4, 7 here. So that's 2. 4's there. 7 there and 3 there. 5, 3, and we're left with 5 and 7. Let's do the maths, ignoring the 9. Got 7, 6, 5, 4, which is 22 plus 2 is 24. Whew! There we go. I believe that is correct. But that is a weird puzzle to work with. I am going to say now that I think I have worked out what Simon meant. And what I think he meant, and I did think of this as we were going along, was that if you added 1 for each cell in a cage to the total, surely this puzzle would become... And then you could solve it for those cages with regular 1 to 9. And then when you've finished, you'd have to subtract 1 from every digit. And when you had a 1, you'd have to make it a 9. So this cage, for instance, would become 13 would be its total. And it would be 6, 4, 2, 1, making 13. And I think it would be a regular killer like that. I'm not 100% sure in what I'm saying, but I'm pleased it worked for the example. And I think that's what he meant. Simon was telling me to do it as it was presented, not to kind of reconfigure the puzzle or even reimagine all these numbers as different. Frankly, I'd have had to start again with a new grid to do that. That's not what he's done. Is it on a video? I doubt it. It might be. I don't know. You will know as much as I do, I believe, by the time you've watched this. And entertaining, a very unusual project there. Thanks to ProwlingTiger for that. Thanks to Simon for insisting I do it that way. You did mess with my head, which I suspect was what you wanted to do. I certainly hope to see you again here soon on Cracking the Cryptic. Bye for now.